Okay, so now let's discuss the second tutorial which also deals with the Python libraries. So the next library that we are going to discuss is the Matplotlib. Now this Matplotlib is a very useful library. It is a comprehensive for creating static, animated and interactive visualizations in Python, which is very useful for any analytical person who wants to use these graphs and charts etc. in a very effective manner. So what is Matplotlib? Matplotlib.pyplot is a plotting library used for 2D graphics in Python programming language. It can be used in Python scripts, shell, web applications, servers and other graphic user interfaces. Now, there are several toolkits which are available that extend Python Matplotlib functionality. Some of them are separate downloads, other can be shipped with the Matplotlib source code but have external dependencies. Now different types of plots can be created with the help of the Python, and these which are available in on your screen, you can see that these are very primitive but they are very effective, and you can create these types of plots or graphs for your purpose of doing your analysis. Let us see very basic codes in Python Matplotlib in order to generate a simple graph. Now these are the basic codes which you can write in the Python and see the result. So from Matplotlib import pyplot as plt. Remember we discussed about the import statement. So plotting to curve the canvas, you can simply write like this: plt.plot 1 2 3 within square brackets and then 4 5 1, and then showing what we plotted. Now when you want to see that what code that you have written, you have to write another line of code, that is plt.show, and this will show you this kind of a plot which is in front of your screen. So with the 3 lines of code, you can generate a basic graph using Python Matplotlib, which you have seen in the previous slide like this. Now let's see some how can we add some title etc. Now labels of our graph created by Python Matplotlib library to bring in more meaning to it, because if there is no title, probably you have to guess it or you have to imagine, but if it is properly labeled, it definitely becomes very useful. So from Matplotlib import pyplot as plt, then x is 5 to 7, y is equal to 216 4, and then these are further is codes plt.plot xy, because x and y are there. Then title you can give, it may be info or whatever name you want to give. Then y label which goes on the y axis, x label which goes on to the x axis, and then you have to simply show that plot whatever you want to create, and this is the kind of graph that you can see. So it is so simple, just by writing some 3-4 lines code you can get good plots. Many styling techniques are available to create better graphs. You can change the width or color of a particular line, or what if you want to have some grid lines. For those options you need styling. Now so let us see how to add style to a graph using Python Matplotlib. First you need to import the style package from Python, which is again a sub library of the Matplotlib, and then you can use it, the styling functions as shown in the as you can see on the screen itself. Now for writing the code, you can write again in the similar fashion from Matplotlib import pyplot as plt, from Matplotlib import style. This is what you want to start is import, so that you can make all those graphs which we have seen in the previous slide. Then style use ggplot. Now this is a type of plot which is available as part of the styling. X, again you have to give all those parameters x and y, then x2 and y2, then plt plot, whatever plots you want to draw. So this is the code that you have to write for that. X, Y, G label, line 1 line width is equal to 5, you can even give the width of the line. Then similarly you can also give the color label is equal to line 2, line width is equal to 5. Then title you can give, as we have seen in the previous slide, y label or y axis label, x axis label, and then you can also give a legend, and then a grid can also be included in that, and then you can show the plot. So this is the script for the basic type of plots that you can create, and see how this can be created. So this is the grid that you can see on the graph, and then the width of the line in the green color and also in the red color, both are there. The legend is also there on the right top corner, that is line 1 and line 2, which is green and red. Title you are seeing epic info, and y-axis is given as y-axis itself, x-axis is given as x-axis. So this is how you can present your graphical details, which is very, very appealing. Then bar graph. Now bar graph is again a very common graph everybody must have seen. So let's understand why do we need a bar graph. A bar graph uses bars to compare data among different categories. It is well suited when you want to measure the changes over a period of time. It can be represented horizontally or vertically. Also, the important thing to keep in mind is that longer the bar, greater is the value, because that is the convention. By convention we always think like that. Now let's practically implement it using Python Matplotlib. So if you want to have a plot like this, again you can write this kind of a code. From Matplotlib import pyplot plt bar, and again you can give all those data points. Then a label you can give as BMW, width 0.5. Then again the second line, further again you can give the different types of data that you have. OD is the label that you want to give, color is R, width is 5.5. Then again legend, then X label which goes into the X days, X label, Y label goes into the Y axis, title that is information, and then you can draw the plot. So once you draw the plot, you will see that this kind of a plot will be appearing. Now you can see that this graph shows that there are two types of cars which have been compared, like BMW and Audi. The title is given as information, and days are taken on the x-axis, and y-axis give you the distance it has gone. So that is how you can prepare a comparative bar chart. In this plot there is a comparison between the distance covered by two cars, BMW and Audi, over a period of 5 days. So that is why 5 days data is available. Now similarly, another graph, that is histogram. The difference between a bar graph and a histogram is not much. Look wise they are by and large same, but histograms are used to show a distribution pattern, whereas a bar chart is used to compare different entities. That is the basic difference between the two. But look wise they look as in the similar, like bars. So histograms are useful when you have arrays or a very long list of your data points. Now let's consider an example where we have a plot the age of a population with respect to bin. Now bin refers to the range of values that are divided into series of intervals. Bins are usually created of the same size. In the below code, bins are created in the interval of 10. That means you can put the bins that you have created, that means whatever comes in that particular range will be available in that particular bin, which means that first bin contains elements from 0 to 9, then 10 to 19, and so on. So like that. Then the code that you can write is similar to what we have seen earlier. Import matplotlib, pyplot as plt, then population age, whatever age data point that you have, bins, whatever you want to create. Here we have taken from 0, 10, 20, 30, 40, like up to 100. Then plt histogram. For histogram you have to write HIST. And then what are the data points in this? That is population age, bins, histogram type which is bar, and width of the line. Then x axis you have the age groups, Y label you have the number of people, and then the title is histogram. When you write this plt.show, then it will be shown on your screen. So this is the way you can have the output. So as you can see, the above plot, we got age groups with respect to the bins. Our biggest age group is between 40 and 50. So this type of graph gives a very good analysis. You can understand that what is the kind of pattern that you have. That is the advantage. Then scatter plot. Now scatter plot is again a very useful plot. Usually we need scatter plots in order to compare variables. For example, how much one variable is affected by another variable, to build a relation out of it. The data is displayed as a collection of points, each having the value of one variable which determines the position on the horizontal axis, and the value of other variables determines the position on the vertical axis. Now again, you can write this kind of a code: import matplotlib.pyplot as plt. X, again the data point that you have, 1, 1.5, 2, whatever you have. Then similarly y, then x1 and y1, two different types of data sets that you have. And then this is the piece of code that you can write, that is plt scatter. Scatter means that you are drawing a scatter plot. xy is again the data point that we are already having, which is high income and low saving, and color is R. R means red. Then the next line that you have is the scatter plot, or dot points that you have is x1, y1. Label is low income, high savings, and color is blue. Then plot x label, saving into 100, and y axis you have the income into 1000. Title is a scatter plot. Legend is going to be available, and then the show. When you show it, it will be again available on your screen. So this is how you can see the scatter plot on your screen, and you can see the legend. Red is high income, low saving. Blue is low income, high savings. So as you can see, the above graph, there are two scatter plots based on the inputs specified in your code, which you have seen, and the data is displayed as a collection of points having high income, low saving, and low income, high saving. This scatter plot is also very useful, and you can draw different types of scatter plot depending on your requirement. Then there is another plot like area plot. Now area plots are pretty much similar to the line plot. They are also known as stack plots. These plots can be used to track changes over time for two or more related groups that make up one whole category. For example, let's compile the work done during a day into categories. Say sleeping. Now these are the activities that you have performed during the day in 24 hours. That is, say, sleeping, eating, working, and playing. Now consider the code. Now this is the type of graph that we are going to have after writing that code. So in this, the code that we are going to write is import matplotlib pyplot as plt. Days, you have taken the data for 5 days, and those four factors that we are considering is sleeping, eating, working, playing, and these are the data points. And then you are going to write your code. So plt plot, then again the codes, color is M. In first case, that is sleeping, line width is 5. Then again the next line, eating, then line width is 5, and again the color is R. Label is working, line width is again 5, and then the last one is color is K, label is playing, and line width is again 5. So when you put all of them together, you'll see that PLT stack plot. Now since it is an area plot or a stack plot, you have to write that, you have to indicate that. That is stack plot, days, sleeping, eating, working, playing, colors, and colors are MCRK, which we have already depicted. MCRK is nothing but a code of individual colors that we will see. Now PLT, X label is X and Y label is Y. Title is a stack plot. Legend, of course, will be there. Then plt.show means that you are going to show that into a graph. So this is the way you will see an output of this. Now you can see that legend: sleeping, eating, working, playing. Now the sleeping is of magenta type, magenta color, which is how many hours in a day that you have spent in sleeping only. Eating, again you can see that how the time has been spent in eating. Working, how many hours you have spent. Then playing, which is in black color. So this is the way you can depict your various activities during the day. As we can see in the above image, we have time spent based on the categories. Therefore, area plot on a stack plot is used to show trends over time among different attributes. So that is how you can depict all such details of your activities. Similarly, you can take any type of data and you can present it in this form. Now there is another very useful chart and very commonly used also, which is pie chart. A pie chart refers to a circular graph which is broken down into segments, that is slices of pie. It is basically used to show the percentage or proportional data where each slice of pie represents a category. Let's have a look at the below example. Now for that you can write again the code like that: import matplotlib. Days, you have again taken the 5 days. Again the same example that we have seen in the earlier slides: sleeping, eating, working. The same data has been taken, but now we are presenting in the form of a pie graph, pie chart. So colors again are same, CMRB, and the code for that is PLT pie. Pie indicates the type of graph, that is pie slices. You want to have the slices. Labels, activities, colors, start angle 90, shadow, explode 0 to 1, auto percentage will also be present, and then the title is pie plot. And when you show it, it will be shown like this. Because we are talking of the slices, it is available, that means slice is slightly coming out of the circle. So that is how you can present. You can see the title, that is pie plot, various activities, that is sleeping, eating, working, playing, and then you can easily understand that how much time has been spent in different activities. So in the above pie chart, we have divided the circle into 4 sectors or slices, which represents the respective category, like playing, sleeping, eating, and working, along with the percentage. Now percentage is also available, that how much percentage of the total time that you have spent on each activity. If you have noticed, these slices adds up to 24 hours, but the calculation of pie slices is done automatically. You have not to give what is the percentage like. You have only written the code and it gives you the percentage also along with the different colors. So the pie chart is really very, very useful, and you don't have to be one who calculates the percentage, etc. It is not only giving you the clarity, but also the percentage, the information. So then multiple plots. Now as we have seen in the multiple types of plots in Python, Matplotlib are available, such as bar plot, scatter plot, pie plot, area plot, etc. Now let's see how to handle multiple plots. For this we need to import NumPy module. Let's see with an example. Again, import NumPy as NP, import Matplotlib, whatever code that you want. You have to define various things, and then you can write these codes. Now these are something which are again available as an example, but you can use your own data point for that. Output would be like this. So the code is pretty much similar to the previous example that you have seen, but there is one new concept here, that is subplot. The subplot command specifies num row, num column, and figure num, which ranges from 1 to num rows, num columns, etc. The commas in this command are optional. If num rows is multiplied by num columns is less than 10, so subplot 2 to 1 is identical to subplot 2, 2, 1. Therefore subplots helps us to plot multiple graphs in which you can define it by aligning vertically or horizontally. In the above example, we have aligned it horizontally. If you want, you can go back and see the code. You can see here how this code has been written. You have to define then what is the kind of calculation that you want to go in for. T1 and T2 have been defined, subplot has been given, then plot T1, FT1, etc. This code, of course, we will discuss when we will go for this, but for the time being, you can see that this kind of code can be created, can be written, and then you will get that kind of a plot. Okay. Then the contour plots, sometimes called level plots, which are a way to show a three-dimensional surface on a two-dimensional plane. Now that is the beauty of this kind of a graph. It graphs two particular predictor variables x, y on the y-axis and a response variable z as contours. These contours are sometimes called the z slices or the ISO response values. A contour plot is appropriate if you want to see how value z changes as a function of two inputs, that is x and y, such that z is equal to function of x and y. A contour line or ISO line of a function of two variables is a curve along which the function has a constant value. So this is how you can see that your contours, your graph is going to be presented. The independent variable x and y are usually restricted to a regular grid called mesh grid, and the NumPy.meshGrid creates a rectangular grid out of an array of x values and an array of y values. Matplotlib API contains contour and contour functions that draw contour lines and filled contours respectively. Both functions need three parameters by x, y and z. The code for that is like this: import NumPy as NP, import Matplotlib. You can see that these are common factors. X list, Y list, for data points has to be there with you. X and Y are again the parameters that you are considering. Z, of course, is another parameter that needs to be considered. Then figure. What is the type of figure that you want to have? Then CP. Then again fig color bar. Axis, set title. You have to set the title, what kind of title that you want to give, and what is the axis, x-axis and y-axis. And then when you write the pld.show, the graph will be presented to you. Code, of course, we are not discussing right now, but because when we'll go to into the data visualization part, we'll discuss all that. Now this kind of a graph will be available to you. Now this, see that how different it is, which is not a common type of graph, but it is very, very informative and very helpful. So this is how you can use your Matplotlib library, which is very useful, and this completes our second part of the tutorial. Thank you.